Hello, everybody. Thank you for joining us today. Really happy to be back here. This is my second time speaking at NDC Oslo. Been here previously also speaking at NDC Security for a different topic. But I always love visiting Norway. Me and my wife actually went into Bergen and took the train and fjord cruise into Oslo, just seeing how beautiful everything is. This talk I really like to give. It's really covers a wide range of topics from my work as well as from helping customers. But it's also just an excuse to get out of the States for a little while, visit this wonderful country and not think about home for a little while. No reason at all. But let's go ahead and talk today about resilient by design, Azure resiliency. My name is Chris Ayers. I was a customer engineer helping customers build reliable applications on Azure. I did resiliency reviews for Fortune 50 and 100 customers. I helped with like healthcare platforms and media platforms and retailers, and so like I looked at the patterns and the things that they didn't consider or they did consider or maybe missed. And that team got disbanded, so I'm no longer helping customers directly. They actually moved me into Azure reliability. So now I'm actually part of Azure engineering, analyzing Azure services, trying to find ways to reduce our outages and incidents to make systems better that provide services to everybody that builds on Azure. You can find me on all the socials except the bottom one and my website. Now, if you want to get these slides, they're on the web. So if you just go out to my GitHub, pretty much all my talks are out here. And this one's actually the first one. And pretty much everything just lives in my slides folder as Markdown, and they're all hosted on GitHub pages. So you can go and review and consume these at your leisure whenever you would like, out at Code Bytes. So we're going to talk about reliability. We're going to define some terms. Why it matters, go over some fundamentals. There's a lot of concepts that when you just say, I want uptime and reliability, maybe you don't consider them. We're going to talk about design principles for reliability and some trade-offs, and we'll do some failure mode analysis and talk about SPOFs, single points of failure. And we'll go over Azure regions and load testing, all sorts of fun stuff. So let's get into reliability. Reliability really matters, and I'm not going to fully drain this slide, but you need to be reliable so that you can deliver services and response times. So that might mean you want consistent performance of a certain level. That might mean that you gracefully degrade. That might mean that you can come back rapidly. For a lot of times when I'm talking to retailers, like in the United States, Black Friday is a big thing where there's a huge spike in traffic. And so most of the year, they might have a ton of systems that are going, recommending things, doing marketing, doing like trying to sell you something else. But when you're getting a ton of traffic, you probably don't need those. And maybe those type of systems turn off so that you can keep delivering traffic. So we just need to really understand that failures are going to happen. It's inevitable in large distributed systems. And you need your workloads to be able to detect and withstand these type of issues, maybe a spike in traffic or a DDoS. You need to be able to recover from them. And if a system goes down, you don't want it to be down for weeks or months. You need it to come back in minutes, if not hours. So that is what we talk about when we talk about reliability. And so anytime there's a gap, there's a failure, there's an outage, it's not only a monetary impact, it's a reputation impact. It's a trust problem. And this is something we deal with a lot. You know, how can you continue to use services that go down constantly? You wouldn't. Failure is always an option. And so the thing that we need to talk about today is how you mitigate that or architect around it in the infrastructure and in the software. Now, like I said, it might just be revenue loss. If you're a retailer and your site's down, you're not selling. That's a direct impact. Maybe it's increased expenses. So if something's down and you have to send workers into a data center to do stuff, there's extra cost. If you have somebody on call that has to go do things, restore services, restore backups, do overtime, those are extra costs that people don't always think about. If you have SLAs, you have legal obligations to provide services to customers, and you're not providing that service, refunds. That's another cost. You might get sued. Maybe your insurance rates go up if you're affecting something and it's not there. And then there's costs, just costs of doing stuff, costs of data recovery, cost of restoring, cost of extra compute, cost of shipping network traffic. So there's a lot of financial impact to an outage and downtime. There was a study by New Relic in their observability forecast that the median annual downtime for high impact outages is 77 hours. Like 2 to 3 days. 146 million annual cost of outages, average annual cost of outage. And 30% of engineering time is spent addressing these. So it is impactful. In a 40-hour week, that's 12 hours a week that you're spending time dealing with outages potentially. So I was told there would be reliability, and there is. Like a lot of times, we deal with 5 nines. Who wants to provide 5 nines of service to their customers? Yeah, it's expensive. You're going to be down 26 seconds this month? 26 seconds. So a lot of times you'll hear about 3 nines. That's 40 minutes of monthly downtime, 8 hours a year. It gets exponential. Now you can come out here and play with this. This is a great little website, Uptime is. You can play around with, 4 nines gives you, let's see here, 8 seconds a day, I think it was. 8.6 seconds a day with 4 nines. And you can do reverse. Let's say you have an outage or an incident or something happens. So you could come out here and say, hey, we were down for 2 hours. So our daily is only 99.1. Our yearly has now dropped to 3 nines, 99.7, or 99.97. So when we think about 3 nines, 4 nines, 5 nines, getting to that is difficult. It's hard. I think I closed the slide tab, so we'll just do this. And I'll just go back to it, whatever. No big deal. So one simply does not achieve 100% uptime. We just don't. So how do we measure this uptime? Well, there's 3 levels that we build on. SLIs are service level indicators. What are the things we're measuring? Are we measuring error rate, calls, success calls, error calls, throughput? Like, what is the thing that you're measuring? Like, that's your SLI. That is the things that you should have monitoring and metrics for. Next, we have SLO. These are targets. This is an SLI over time. So, what's our uptime per month? Our error rate every hour, something like that. And then SLAs are the things where lawyers get involved, where now you have contracts, and maybe you owe refunds. So these are different levels, and these are things we play with. And so we're going to have a lot of SLIs, we're going to have fewer SLOs, and hopefully you have less SLAs as you think about this process. The other thing that we measure a lot of time is RPO and RTO. And these are very common, recovery time objectives and recovery point objectives. And you can easily see like, hey, we had a disaster of some kind. So our recovery point objective is how much data can we lose? Can it be 15 minutes? Can it be an hour? How much data can we lose? And then how long does it take to get back? How much time can we afford to be down? So we got a couple ideas on how to measure. Let's start looking at how we implement it in Azure. So there's actually some really good guidance. But like with every cloud provider, and this doesn't just apply to Azure, this applies to If you're in a colo or a data center or some other cloud, there's probably some sort of shared responsibility. You're going to have some things that are given to you that the provider will manage, and then there's going to be some things that are yours. And depending upon what you use, that might have a different level of responsibility. For like the data center, you probably don't have a lot of control in that unless you have a colo or you have your own data center, if you're using a public cloud like Azure. You get to a point where none of the physical stuff you have access to or that is your responsibility. What is your responsibility is when you start looking at IaaS and PaaS. So when we're doing VMs and we're doing infrastructure as code and we're doing infrastructure as a service, we're dealing with stuff that is more lower level. I need some storage, I need a virtual machine, I need a network. And so you have a lot more control and responsibility for maintaining those things. If you want multiple VMs to be highly available, you're probably going to have to spin up multiple VMs, and you control the application and the OS and all sorts of stuff. As you start shifting to PaaS, the platform as a service model, maybe you're running Kubernetes or an app service or something in the cloud, you really just care about your application and your data and your accounts. So, there's areas where you can play more with reliability, and there's areas where you just accept it from the provider. And it's your choice on where you want to be in that spectrum. Now, Microsoft put out the Azure Well-Architected Framework. There's other well-architected frameworks, but this is their guidance on how we build high-quality applications. And there's a number of pillars that we're going to go through the reliability pillar some. There's trade-offs, there's design decisions and recommendations. And this is, affects all the different people in your org. So there's 5 pillars: cost, operational excellence, security, reliability, and performance. And, reliability, of course, is about resiliency, availability, and recovery. These are 3 different things. Like, can we withstand load and traffic? Are we going to be available? And can we get back? Security is about not only data, it's about identity, and it's also about mitigating risks, maybe from our supply chain, if we have vulnerable packages. Cost is always a big one. I want to keep my costs down. I want to have a budget. Operational excellence is those patterns and practices that we want to exhibit all the time. Observability, monitoring, safe deployment, zero downtime deployment, potentially. So these are things that you get out of operational excellence. And then performance. Is it scalable? Can you do load testing? Is it meeting the performance metrics that you're looking for? Completes operations in a certain amount of time, things like that. And so there's some design principles that I think really resonate when you think about resiliency if you haven't gone through these exercises before. The first one is, what are your business requirements? So we talked about those 5 nines are really hard to get to. And I know if you talk to an engineer, that's a non-functional requirement for a lot of us in some cases. Like, what exactly is the performance metrics we're shooting for? PMs and managers are going to say, we want uptime all the time. We just want to always be up. It's like, okay, what is our business requirement for our customers? Do we have customers that are only going to use our application 8 to 5? They're all local. Do we need a full global deployment with 24/7 uptime and multiple redundancy? Does that make sense for our requirements for our customers in our town that we're serving? And that's it. Maybe not. So what are your business requirements? Like, what is the actual use case of your workload? Like, the requirements for a mom and pop shop are not the same as the requirements for Walmart or Tesco. They have different needs. Do you have, like I said, traffic patterns that like they sign on at 8 and they sign off at 5, and so you have defined traffic patterns that you're going to identify in use cases? Does it shift to a global thing? Maybe you can change your access patterns across the globe. Do you need the same level of resiliency? Is it for a government and there might be a regulatory or a compliance need? What are those requirements that you have to target? So set success. And the requirements might be different for different components in your system. Every piece of your system might not have the same uptime or requirement. Like your logging and your authentication system might be very different than like a marketing system. They might have different requirements. So understand each one, understand the compliance needs of each component, check out your dependencies. We are going to talk a little bit about composite SLAs because that's a fun one. You know, if you're building a reliable system, it is built upon all of the components you're using. You know, we've got to think about resilience. So how do we fail gracefully? Like, how can we architect our system to continue to operate even though we have a failure? Can we circuit break part of our system? Can we understand scaling limitations and maybe put rate limiting and throttling in place if we're getting a load of traffic? So how do we, degrade gracefully? What are our critical and non-critical components? What are some places we can fail? And we'll talk about failure mode analysis in a little bit here. So there's a lot of different things that you need to think about rather than just, I want to be up. We talked a little bit about RPO and RTO, but this is definitely part of recovery. So assume a failure happens. Assume something goes down. How do you get back? Are you using persistent messaging? Are you doing, backups and offsites and multiple regions for data? Like, how do you deal with those type of issues? Maybe you don't need to, but maybe you do. What about operations? Do you have an observability platform in place? So Jimmy was just up here. He was discussing adding OpenTelemetry to brownfield applications. What is your monitoring and observability solution right now? Are you having a central place where you can start detecting failures? Do you test and validate that? Like, are you doing regular load testing or performance testing or chaos testing? Do you have metrics on that? The biggest thing is keep it simple. Like, it's very easy to over-engineer. So if you're an engineer on one team and you're like, we know our load, but we should probably have 2 or 3 instances or bump it up 20% to assume for traffic and growth. And then the PM or the next layer up goes, hey, we should have 20 or 30% more just to make sure we account for growth. And if you keep doing this layer by layer, you start having a way over scaled system. So keep it simple, but then do testing and validation and plan for that. If you over-engineer extra layers and things in place early, then you have this extra complication where you're coordinating lots of pieces, and that becomes a very, very big problem. So let's get into some specific trade-offs, and we'll get down into some implementations. So there's a lot of trade-offs between resiliency and cost, security or performance. And so this is where you really need to understand what the goal is. What is the thing you're trying to do for your customer? What is the thing that's most important? Like if it's a healthcare application, resiliency might be more important than anything else because maybe their heart monitor goes out. And if you're not monitoring that and the platform is down, someone could die. If it's pizza delivery and then your pizza order doesn't go through, that might be a different level of resiliency. So understand the trade-offs. This is the one I always get. Every single time I bring up resiliency with a customer, if they've never had an outage, they go, that might be too expensive. Can we turn it down? But if they have had an outage, if they've been impacted, if something has gone down and they've lost revenue and they've lost trust from their customers, this doesn't matter anymore. They don't care about the cost because they understand the pain of losing customers, losing reputation, and having an outage. But sweet summer children. When they don't have an outage, this is always the look. It's always like, but cost. My manager won't approve it. You sure we need 3 instances? Maybe we can get away with 1 or 2. So, cost. So, if we want to prioritize reliability, we need probably multiple regions. If you have an application and it's all in East US, maybe you need one in West. So you now have twice the hardware or twice the scale that you have. in order to support some sort of redundancy. Something can go down, the other stuff can still be running. That's double your costs. Boom. How important is uptime to you? Maybe you don't want to monitor everything. Logging is expensive. Logging is hard. We'll just sample every 5-10 minutes. What's the worst that can happen? Keep the cost down, right? With observability, we probably want something really, really robust and thorough. We also probably want to have additional traffic to handle spikes. But it's hard to justify unused capacity when you're focused on cost optimization. That's where auto-scaling comes in, but then you might have to understand auto-scaling has a lag time. There's like sliding windows and algorithms, you can tweak them, but a lot of times, I've even seen it inside Azure. Sometimes the auto-scaling takes a while, and they manually crank it up because it takes too long for the algorithm to work its way through the scaling. What about security? We probably want lots of backups of our data. Oh, that's a larger attack surface. People can go find backups, get access to things. Trade-offs. So we can have quicker recovery, but now we have more data with more access to it. We want something to be stable and reliable and not updated instantly, but we want to update it instantly because it's vulnerable. Who's ever delayed upgrading a library, a version of something, a NuGet package, an NPM, because they don't want it to break when you deploy it, right? Yeah. Trade-offs. Operational excellence. So as we start scaling things out, now we have multi-region. Maybe we have hot or hot-warm or log shipping. It starts to be a little bit more complex. So that means our deployment pipelines are more difficult. Our monitoring is more difficult. How it all works is more difficult, which means our documentation, our training adds overhead. It's harder to onboard teams into the environment because it's more complex. It's real easy when it's in one region and you right-click deploy. Don't do that. Don't do that. Don't do that. Anyways, and then performance. So instead of just writing to your database, now you put it on a message bus. You're using distributed, eventually consistent databases. Things start slowing down because you have global data stores now instead of a single database. So maybe you have a little bit slower reading and writing. Maybe you have to do some new systems to handle, has that message been processed or not processed? So it adds some layers of slowness, potentially, into the process. So there's lots of different trade-offs here that you need to think about. And that brings me to failure mode analysis. So this is where you not only need to think like a hacker, you need to think like Murphy's Law. You need to think like, what's the worst that could happen to our system? What if the power goes out at that data center? How do we keep operating? Are we in another data center? What if the router goes out? Do we have global networking in place? So you need to look for weaknesses in your architecture, in your infrastructure, in your software even, before they happen. So this is where it can be fun or challenging, depending upon how you want to look at the puzzle or the problem. When you've had outages, do you do root cause analysis? Do you go and look at what happened and identify the systems, the components? That way you can kind of prioritize these. And obviously, not everything happens. Like the odds of a meteor hitting your data center are low. The odds of screwing up a deployment and removing the permission are probably higher. So prioritize things based on the chance it could happen also. Like this is what we do in risk where I work. We talk about this stuff. We identify those single points of failure where if we're only running one of it, if everything's been routed through it, that's the area we target first. We want to remove our SPOFs. We want to identify those places where we can add redundancy in. And again, this can be in code, in data, in infrastructure. There's actually a great article, and I'll go to it because I want to talk through some of this with us. So I mentioned that the well-architected framework, there we go, has a bunch of things here. It has design principles, checklists, trade-offs, but it has all these recommendations. And I highly recommend you dive into these and like take a look at them. But I think that this table is a really great example of what a failure mode analysis looks like. You know, like what are the odds that Entra ID is going to go down? The likelihood of it. I mean, right after an outage, it probably feels like it's higher. And when I look at the outages and incidents that go through Microsoft sometimes, it feels like it's not low, but the odds are low. But what happens to your workload if your identity provider goes out? You're probably dead in the water. Like, oh, nobody can sign in. So understanding, oh, we have a full workload outages. We are dependent on Microsoft to go resolve this, and this is just going to knock us out if we have a problem. But we documented it. We know about it. What if we misconfigured it? What if we screwed up an identity or a scope or a permission? I mean, that's us. Like users might not be able to sign in. Like a lot of the services are going to be running, but just people who are trying to sign in won't be able to now. So now we're going to have help desk tickets, and it's going to be isolated potentially to some groups of people. So you start gaming through different scenarios in your head and looking at your configuration and looking at your architecture and looking at your code base and go, where are the places where we can fall down and break? Front door, like if front door has a problem, you know, it's a regional problem. Maybe we have an instance in another organization or another region. And we can look through a lot of these, like they've done it component by component. We depend on front door. Let's analyze our front door configuration. Here's SQL. What are some problems if we have an availability zone outage in SQL? Nothing. It doesn't affect us. So I highly recommend that you look through some of these examples. They're very helpful. All right. So regions. I mentioned that availability zones might not affect us if we're using the right services. So there's over 60 Azure regions. There's a number in Europe, a number in the States and most continents and countries in the world. Each data center has a connection through the Microsoft backbone. So low latency, high capacity networks. There's even some sovereign clouds. So there's some for different governments. Don't get me started. And there's a great application out there, the region map. So these are all of the regions that are out there. So we come over here. I think there's a few in this region, just a couple. And you can see some of the connections between them. So thinking about performance, reliability, regions are geographically dispersed. So usually something affecting one region does not affect another region. So if you're just worried about your hometown, pick a region near you. You'll have low latency, good connectivity. But if you want something global, maybe pick more than one. And that's where the idea of region pairs came in. So this was one of the first concepts that they had in Azure. So they had paired regions, like East and West US. And so like East would get some updates and then West would get some updates. So if you were in paired regions and they screwed up something in one region, the other region would be fine because it wouldn't be getting those updates yet. And it also has better recovery between them. So like if your East went down, maybe you were able to restore much quicker for your databases or files in West. It doesn't guarantee automatic failover, but it like had good high-speed connections. Now the problem is everybody was using paired regions, or a lot of people were using paired regions. So when something went down, everybody on those paired regions would flood to the other side. And you start seeing some traffic or capacity issues. And so there's also non-paired regions, and this is where you can make your own reliability choices. Like I might have load balancers in front of two non-paired regions, but I'll do my own geo read or recovery across whatever. But And this is where we were doing, I want active-active. So for really large organizations I've worked with, we do active-active. We have data in both regions, compute in both regions, maybe with regionally isolated identity or compute. That way, they didn't really need to share, or it would route to the appropriate place. And we would have something like front door or traffic manager in front of it to load balance. Active passive is you would just write to one region, and the other region would be getting data backups or eventually consistent access to a database. So read and read write on the primary and maybe read only on the secondary until it fails over, and then read write on the secondary. Like this works. This has worked for years. This has worked for tons of people in data centers for a long, long time. But we've been doing something a little different for the past couple of years with availability zones. And this has really been a big push where you might not need multiple regions if you don't need that sort of scale. And there's a lot of services that just work with availability zones, and you just get extra redundancy without really having to think about it. So availability zones are data centers inside the same region. So in East US, there's at least 3 data centers, zone 1, 2, and 3. They're geographically dispersed. So even though they're all east, they're quite a distance apart. They have independent power, independent network, independent cooling. And so, like for normal things, they have extremely low latency connections between them. And most services support availability zones, and most regions do. There's actually documentation. So if I go look at my regions list, you can see there's a region coming, or it's restricted, if they have a paired region, if it has availability zone support. So you can actually go through and find a nice selection of availability zone support near you, or a region near you that you want to leverage. Okay, stop doing that, thank you. But there's also different types of zone support. So let's say you have availability zones. Not all services support availability zones. Some do, some don't. And this is like, if you take nothing else from this talk, I think understanding what zone redundant and zonal mean and how to leverage those in your solution. So you're going to see there's checkboxes for zone redundant and zonal based between different services. And it is going to keep shifting towards zone redundant kind of across the board, but there are some services where I don't think that will ever be possible. So, zonal. Zonal means it's pinned to a data center. So when you have a VM, it's going to run in a data center. It's not going to run in 3 data centers. It's going to run in 1 data center, probably with the same network and storage. So if you use a zonal service, you get 1. If you want to make that redundant, you got to have more than 1 and have a load balancer. That's on you. If you use zonal and you want it redundant, you have to do it. So you have to deploy the resource in each zone. You have to configure it. You have to replicate it potentially. You have to have a load balancer. And now guess what? That load balancer kind of looks like a single point of failure, maybe, depending upon the one you choose. So you can have some issues here. Like, where's that load balancer run? Does it run in zone 1 or 2 or 3, or is it outside your zones? Are you doing front door to load balance? Like, if you have one box, that's where you think about, is that a single point of failure? But this is where you choose. Like, you have the most control. If it's zonal, you can choose. Do you want active-active? Do you want active-passive? Do you want a load balance between them? How do you want to handle redundancy? It's on you. If I go zone redundant, let's say I use a VM scale set, and I say, use availability zones. It's going to run them in multiple zones. It's going to load balance between them. Like, it'll handle it. Like, if I say I want 3, and one region goes down, it'll spin up a second one in one of the other regions that's still up. That's the idea behind zone redundant. We handle the routing of traffic between them. We handle the maintaining multiple instances. So, zone resistant resources are ones where You've deployed multiple zonal things and made it resistant, or you use our zone redundant stuff. It can survive a single zone going out. So it can survive a data center. So if there's a cable cut at a data center and it's no longer on the network, things in that data center will go out, but hopefully the traffic will bounce over to the other availability zones. It just minimizes downtime, and the non-zonal stuff, you can put it anywhere, and it really is up to you if something happens. If something goes down, it might affect you. So if I just say I want a LRS storage account, I want local storage, there's like 9 copies of the data, but they might all be in the same data center. So if a rack goes out, it'll survive, but if the data center goes out and I have a VM attached to it, the VM is probably going to reboot and go down because it depends on something. Now, when we use multiple availability zones, Microsoft updates them one at a time. That way, if something does go bad, it's isolated to a single availability zone and it's not everywhere. Now, I mentioned LRS. So Azure Storage has a couple of different choices. So LRS is you actually have 11 nines of durability. So durability is an important aspect to resiliency. Like just because you have data doesn't mean the data is valid or good. You can have bit rot, you can have corruption. So having durability means that your data is reliable. Like it's the data you expect to get back. It's not corrupted. When you have LRS, it's just multiple copies in the same data center. When you start doing the ZRS, which is the next step up, there's like 3 copies of the data, I think, in each data center. So you pretty much have data in all of your regions. Then you can do GRS, so you can have multiple replicas in 2 different regions. So if your main region goes down, you can still get to your data because it's going to come from some other region in Azure. And then there's RAGS, which is GRS with read access. So, like, again, you can choose, remember that shared responsibility model, you can choose by choosing the right SKU and choosing the right architecture how reliable you want your stuff to be, how reliable you want your data access to be. And there's different patterns that you do for different scenarios. Like I said, it depends on your business requirements. Not everyone is Walmart, not everybody is a mom and pop local shop that has their geo pages set up for their small business or uses Square or Shop. Like there's a spectrum of choices. So maybe a line of business app just needs to be reliable with minimal downtime. You might choose zone redundant. But maybe it's an internal app that you're just POCing and trying something out that might have different requirements. Or if it's healthcare or banking or SaaS, you might have different SLAs and contractual obligations. So you choose from this toolbox of things on how you want to use it. Now we can really enhance our reliability by architecture. We're trying to isolate failures, we're trying to distribute workloads, and we're trying to use availability zones where they are. And there's a lot of good design patterns and reference architectures that we can use. But what I always tell people is if you're just architecting solutions and you're just drawing boxes and arrows, you don't know if it survives. You don't know if you're reliable until you start load testing. So, and there's different types of load tests. Like there's a soak test where, if you want to be able to handle 100 requests per second, send it 100 requests per second and just hold it. If you're supposed to be able to do that load for hours, then nothing bad should happen. You shouldn't have a bottleneck where it starts to build pressure in parts of the system, and then your response times start to tank after 30 minutes, and then now you can't meet the definition. You've identified a problem that you didn't see because you were just holding traffic. Maybe you do a spike test where you do like 2 or 3 times your expected traffic, and you've got a big rush of customers, and then you drop it back down to below your minimum. And just to see, does the system recover from that spike? Does the flood get mitigated over time? Maybe you want to just do a stress test and just keep building traffic until the whole thing crashes so you can identify the weak points and single points of failure and bottlenecks. There's different types, but understanding how your system behaves at load, at scale, is important. You can't just design it on paper. You have to test the living thing. Does your auto-scaling work? Does your monitoring work? Did you see why it failed and where the traffic and where the pressure went? Like, it tests all parts of your system. What's great is you can put this in your pipeline. So you can run these things on a schedule. Every time you check in, you can do a load test and check for performance. There's Azure Load Testing Service. You can use Playwright. You can use Selenium. There's all sorts of options, but most of these can be defined in code and run on a schedule or run on a pipeline. And yeah, people might complain, oh, we sent a lot of traffic to our system. We maxed it out once a month. Still cheaper than an outage. The other thing is chaos engineering, so chaos testing. And this is another fun one. I highly recommend doing it as well. What happens when you simulate a zone failure? What happens if you simulate, I can't access my key vault? Does the system break down? Does it fail over properly? What happens if we just turn off a cluster? Does it hop to the other cluster, send the traffic there? So there's different ways to do this. You can validate these things. You can validate networking issues and low latency problems. There's an Azure Chaos Testing or Azure Chaos Studio, but there's a ton of open source tools that you can leverage on Kubernetes and AKS to simulate a lot of these things. CPU pressure, memory pressure, network traffic, killing off random pods, killing off nodes. All of these things you can validate and test, and you can do it in a pipeline. I have some links to a bunch of samples, and I'll point you guys at a couple of them as we go. But these are things you do during business hours when people are on call. Because you want it to happen when people are ready. You don't want it to happen at 2 in the morning when you're not planning on it. Again, test your boxes and arrows. Make sure they actually work and scale. So find these issues early. You have more confidence because you've done it. You've tested it. You validated it. It's going to reduce your time to recovery and time to detection. Some of the numbers that we look at every week on reports at Microsoft, we call them TTX. Time to detect, time to respond, time to mitigate. These are the numbers we're trying to drive down constantly. And so if you're not looking at these and simulating these, they might not work if you haven't tested them. Start very simple, and you can build from there. Have, like they said, game days, schedule it, and build it in your pipelines. Practice this. We get better at stuff because we practice this. This is where operational excellence comes into play. When I talk a lot around DevOps and people do a deployment and they have a failure, then I hear well, maybe we should move to 3-week sprints and we should do a hardening week. Has anyone ever heard that one? We screwed up, let's do a hardening week? Okay, what happens when you screw up in the hardening week? Do you let's just deploy every other sprint? Let's deploy once a quarter, once a year? Now you're not really good at deploying. You're bad at it. You get better at it by doing it more often. So if you're not testing your logging and your recovery and all that, you get bad at it. So practice this stuff. So there's a lot of resources and architectures and references out there that we can point at that show us, like Jimmy was saying, how does Aspire do it? How do Microsoft implement these things? And what are the tools I can use to check these things for myself? So I'm sure you've heard them before, landing zones. A lot of times landing zones have a good foundation. They have isolation and identity and networking and application subscriptions. I usually recommend pointing at them, maybe not something super complex like the enterprise one, but I recommend landing zones. The Architecture Center itself has some really good, interesting solutions that you can play with there, and you can actually come in here and browse them and look for specific architectures and things. The well-architected workloads. Now this is one that I actually really enjoy. So I'm gonna, there we go, open it in a tab. So as we've started to build things, they have some specific requirements we have to look at. There is an AI workload where there's a recommended guidance and sample solutions that we can dive into for a baseline OpenAI architecture, where we want it to be resilient, following the best practices. Maybe we put an application gateway or AI gateway in front of our ChatGPT instances. Maybe we have redundancy built in. So it's not just the generic recommendation on how to build a solution, it's one that is well architected and aligns to our pillars, like VMware, SaaS, SAP, and then there's mission critical. So we actually have a mission critical workload as well that you can go look at and dive into, and there's some sample infrastructure as code, there's sample pipelines, there's sample code. One of these is the enterprise app patterns. Like that's something that we've also started to build out, the enterprise web app patterns, and they have a .NET implementation and a Java implementation. And this really aligns with kind of what I was talking about before. Let me go to, I'll just pick the .NET one for now. They're going to go through not just, here's a pattern. They go through all of the logic and thinking and why we chose this component. What is the guidance we have? What is the SLOs that we can reach? And maybe we start with a stamp in one region. We have our application, and we have configuration, and we have caching to help with scale. We have private endpoints to help with security, and we have performance monitoring in place. But maybe as we start scaling out, we add other stamps. We start expanding it. So we think about the components in isolation, and then we start looking at how we can remove the single points of failure, start adding additional components to scale our workloads. And this is all documented. They even have, like, you can use hub-spoke technology. They talk about why they're picking each different component with the SLAs, with the management overhead, because like we said earlier, it's not just about the technology. Sometimes it's about the hours you have to put in maintaining it, restoring it, configuring it, caching. So these patterns are available for you to use and build with. Another thing that I leverage a lot, does anyone do Terraform or Bicep or ARM? Okay, a lot of hands. Who goes out to the Azure resource learn page and looks at the documentation specifically for your resource and then like copies that Bicep or that Terraform sample and then like wraps it in your own code to make it plug into your internal libraries? Anyone make their own like Bicep libraries? Yeah. You don't need to do that. I wouldn't do that as much. But so Azure Verified Modules, I've actually helped make a couple of these. We had like 2 or 3 different initiatives inside Microsoft a couple of different times, and they all kind of failed at some point. We had the Bicep like standard library. We had Terraform modules. So Azure Verified Modules is actually every component is supposed to have a Microsoft full-time engineer assigned to it so that we can respond to issues, make sure it builds, update it when the resources get updated. We also have wrappers for each resource that align to WAF. So they're secure, they're reliable, they have samples on how to leverage them. And then we have patterns on top of that. So let's say we look at Bicep. So you can see we have a ton of published modules. We have owners for each one. We have status of our build. We got AVM. There's over 100. Let's just look at, there was one I was looking for. App Insight, whatever. If I come here, I'm going to see information about everything. It's going to document the types and API versions it uses. And then we have these uses examples. I just want to reference it from a module. And so I don't have to have it in my code. I don't have to have it checked in. I can actually just register it from the Bicep public registry and say, just go use this version of the official AVM published module. I'm just going to consume that straight off the internet, and here's some parameters I need. But maybe I want a more complex parameter, or I want to use a large parameter set and like really customize it. Like they've already taken and aligned and exposed all of the properties of the resource in an easy way for you to tweak and consume. And it's all documented quite well. Like the type, what it is, how to use it, and the outputs. So stop wrapping the documentation with your own classes. Like leverage these. These are supported. I want to recommend that. Like I really do. And then, like, let's say we look at Terraform, and we have some Terraform patterns. Well, I can come down here and look at some of these. So we've got a like hub networking Terraform module. Landing zone firewall. And there's all the Terraform documentation for it and how to configure it. So all of the hard work's been done on both Terraform and Bicep, and they are wrapped with resilient stuff. Like it has a default recommendation for maybe multiple instances or a configuration with the right SKU that will help you, or availability zones turned on out of the box. Like these are simple things that are easy to forget. And there's actually a lot of services out there that if you, let me just go here and go Azure availability zones. If you create a service without availability zones, not all of them let you migrate. So like for some of these, you can. Like if I have a container registry, I can go enable it. But for some of them, it's like you can't do this after creation time. Like you have to delete it and make a new one if you want availability zone support. So if you're doing it through infrastructure as code and you're doing it with the modules, you're going to get that stuff turned on by default. There's also April. I don't know if any of you guys have heard of this. Let's say you have already deployed your solution and you want to test it. You want to see how resilient you are. Are there things that you missed? Are there configurations that you should do? So April is a series of PowerShell scripts and that call out to the Azure CLI. All right, there's the GitHub pages site. So it queries your active deployments. It actually looks at what you've deployed and how you've configured it, and it checks, did we configure it right? So if I look at like my Key Vault should have soft delete. They should have purge protection. This is actually going to check all of your Key Vaults and see if they match. A lot of these recommendations you might see also in Advisor. Azure Advisor will have some resiliency recommendations, but these go far beyond it in some cases. And these will like dig into like your container services, your compute services, your like Kubernetes clusters. Did you isolate your system and app pools? Do you have monitoring? Do you have a SKU for highly available configured? So you can just run this on your subscription, your resource group, your individual components, and get a report back on areas you can adjust today. Like, there's also Azure review checklists. So I've contributed to AVM, I've contributed to April, and my team before, when we were in Fast Track, we wrote these review checklists. These review checklists were, again, built by Fast Track for Azure. And so you will pick a workload and be like, hey, I want to go check for security, for reliability, for a landing zone. And these are just questions that you can go ask yourself and go check out in the portal and see, have I configured things properly? So, focus on your design principles, understand your requirements, understand your components, understand what the business is trying to do, and get the right level of reliability, recovery. Understand those trade-offs. Make sure you're not just looking at the cost cutting, and understand that there's going to be impact. Test these things continuously. Like try a load test, try a chaos test, play with this stuff. All the resources are available out at GitHub on my site. Please go check out April, AVM, the checklists, and the enterprise web apps. And with that, questions. I want to make sure, I've helped a lot of customers do a lot of things, and I'm sure that there are some specific questions about reliability or resiliency. So if anyone has questions, I'm more than welcome to take them now, or afterwards I'll be around. But thank you guys.